So we'll continue the frequency response plots under this Bode plot. So previous classes we will cover that what is the basic procedure for constructing the magnitude plot and phase plot. And today we'll see gain margin and phase margin, how to find out the gain margin and phase margin from the Bode plot, and how it will be affected on the stability. So basically the system is said to be stable or unstable or marginally stable. So based on this gain margin and phase margin, we can decide whether the system is stable or marginally stable or unstable. Okay. Okay. So before going to that, how to find the gain margin and phase margin? So let's have a small definition regarding this gain margin and phase margin. What is the gain margin and what is the phase margin? These are the two important parameters. Okay, gain margin and phase margin. These are the two important parameters while you are calculating the stability of any system. So gain margin. How to define the gain margin means the gain margin is the reciprocal of the magnitude of the open loop transfer function. So if you want to calculate in terms of logarithmics, so reciprocal means what we will get? So 1 by something. So 1 by modulus of g omega. G of magnitude of g of j omega. Okay, but here this magnitude is calculated at a frequency. That frequency will be known as omega PC. Omega PC means phase cross over frequency. Okay. So just once again, the gain margin is calculated. The gain margin is the reciprocal of the magnitude of open loop transfer function. Or else if you want to tell in terms of logarithmics, we can write minus 20 log of some 20 log of g omega. So this is a value. But where you have to calculate this magnitude at what frequency you need to take the magnitude means the frequency at which omega equivalent to omega PC. So at this corresponding frequency, we need to take the magnitude value. What is omega PC? Omega PC will be known as the phase crossover frequency. So what is the meaning of phase crossover frequency means? So the frequency, sorry, once again. Okay, here, see that omega PC, omega PC. So omega PC indicates that the frequency at which the phase angle is minus 180 degrees. Okay, see that the frequency at which phase angle is minus 180 degrees, that frequency will be known as the phase crossover frequency. Exactly at this frequency, if you are extended the line, this line will touch the magnitude plot, right? So at this point, how much amount of magnitude will be there? That magnitude will be considered as the corresponding gain margin. Corresponding gain margin. Is it clear? How to calculate the gain margin? The gain margin is the reciprocal of the magnitude. Gain margin is the reciprocal of the magnitude and it be calculated at a frequency of phase crossover frequency. The phase crossover frequency is nothing but the frequency at which the phase angle is minus 180 degrees is known as phase crossover frequency. That means exactly that value. How much magnitude will be there? That magnitude you can take directly. For example, I am taking that at a frequency 10. At the frequency 10, the slope is minus 180 degrees. Then this 10 frequency will be taken as the phase crossover frequency. Exactly at 10 frequency, at the frequency 10, the magnitude is, for example, minus 20. Okay, minus 20. So then what is the magnitude you have to take directly? Because it is a logarithmic, so directly I am taking the minus 20. So already it is a minus. So minus of minus plus. So plus 20 decibels. So gain value is negative, then the gain margin is positive. Okay, please remember that. If gain value is negative value, then the gain margin is positive gain margin. If gain, observe this omega PC. Here omega PC, what is the meaning of omega PC? Phase crossover frequency. That means the frequency at which the phase angle is minus 180 degrees. Exactly this point. So what we are doing, how to calculate the magnitude across this point? Simply we are extending the dotted lines. It will touch the magnitude plot at this point. So here, how much amount of magnitude, for example, I am taking that plus 30 decibels. So gain is 30. What about the gain margin? What is the formula for the gain margin? Minus of 20 log of something, right? So that means gain margin is minus 30. If gain is positive, then the gain margin is negative. So please keep that point in mind. Okay. If the gain is negative, then the gain margin is positive. If the gain is positive, then the gain margin is negative. Okay. Clear? How to calculate the gain margin? Just once again. Gain margin will be the defined as the reciprocal of the magnitude of a open loop transfer function g of j omega. Sorry for inconvenience. Okay, is g magnitude of this function at a frequency of omega pc. Okay, omega pc. What is omega pc? Omega pc is the phase crossover frequency. How to get the phase crossover frequency? From the phase point. At what frequency you will get the minus 180 degrees, that frequency will be known as the phase frequency. Exactly at the same frequency, you can extend that line, it will touch the magnitude plot, then the corresponding magnitude value will be known as the gain value, the corresponding gain value. Then from that, we need to calculate the gain margin value. Clear? So if gain is negative, gain margin is positive. If gain is positive, then the gain margin is negative value. Right? Next, second one. While you are calculating the phase margin, what is the formula for the phase margin? So phase margin can be calculated as gamma equivalent to 180 plus pi gc. Gamma equal to 180 plus pi gc. So this is the formula for the phase margin. So here I have one question for that. Why we need to calculate the gain margin and phase margin? What is important? Because if a system is said to, if a system is at a position of marginally stable, that is marginally stable means it is not a stable system, it is not an unstable system. It is exactly on the boundary line. For example, if you want to improve that, its a stability point of view, you need to add some amount of gain so that it will become stable system. So how much amount of gain you need to add to the given system, that will be known as the gain margin. And how much, similarly in terms of phase also, how much amount of phase should be added in order to bring from wedge of instability to the stability region. Okay, that's why we need to calculate this gain margin and phase margin. It's nothing but gain margin and phase margins are nothing but we're adding some additional amount of gain or phase values just in order to bring from that instability region into the stability region. Okay. So what is the formula for this phase margin? Phase margin can be calculated as gamma equal to 180 plus pi gc. So what is pi gc? So pi gc is nothing but it is the phase angle of the open loop transfer function g of j omega. Okay, phase angle of g of j omega. But where at what frequency you need to calculate this phase? That means this phase angle will be calculated at a frequency of omega equivalent to omega gc. Omega gc. What is omega gc? Omega gc. Omega gc is known as the gain crossover frequency. Omega gc is known as gain crossover frequency. What it means that the frequency omega gc will be indicates that from the magnitude plot. The frequency at which you are getting the magnitude is 0 decibel. The frequency at which the magnitude is 0 decibels, it is known as gain cross over frequency. The frequency at which the magnitude is 0 decibels, the frequency will be known as gain crossover frequency. So then this line will touch the phase plot some point, right? For example, if you see this, it will touch the slope line across to some point. So it is in the lies between how much value minus 90 to minus 20, minus 180. It is around, I can think that it's, for example, minus 150 degrees. Minus 150 degrees. Then what is the phase angle now? Gamma phase margin, gamma equal to 180 plus how much angle you need to consider here? How much it is? Minus 150. So that is 180 minus 150. So that is 30 degrees. Clear? So in this way, we are going to calculate the phase margin. So here, coming to the conclusion of this phase margin and gain margin, see, when the phase value will be lies between minus 90 to minus 180, that is less than minus 180 degrees, you will get a positive phase margin. For example, if you are having the value greater than minus 180, then you will get the negative phase margin. Did you get? So when you are getting the positive gain margin, when you are getting the negative gain margin. Similarly, when you are getting the positive phase margin, when you are getting the negative phase margin. So positive gain margin means when the gain value is negative, then the gain margin is positive. When the gain value is positive, then the gain margin is negative. Similarly, if the phase value is less than minus 180, then that phase margin is positive phase margin. If the phase value is greater than minus 180, that is lies between minus 180 to minus 270, then you will get the negative phase margin. Okay, but the important point we need to consider here, positive gain margin or negative gain margin is not the thing. But what range of frequencies you are getting, this positive gain margin and negative gain margin is important. See, the relation between omega GC and omega PC, that relation is very, very important. If suppose omega GC value, okay, here I will show you that. Here, omega GC, let this point. Okay, see this condition. Omega GC and omega PC. Omega GC and omega PC. Here, omega PC and omega GC. What is the relation? Can anyone tell? Omega GC value should be less than omega PC here, right? And omega PC is less than omega GC here. So coming to that, if omega GC value is less than omega PC, then we will get that positive phase margin, positive gain margin, and the system is said to be stable. Stable. What is the condition for the stable? Positive gain margin, positive phase margin. When you will get the positive gain margin and positive phase margin, if omega GC value is less than omega PC value, then the system is said to be a stable system. If suppose omega GC value is greater than omega PC, very clearly. If omega GC value is greater than omega PC, then what will get the resultant? We will get the gain margin is negative as well as phase margin is also negative, and we had said that the system is unstable. Unstable. Okay. Omega GC is less than omega PC. System is said to be a stable system. Omega GC is greater than omega PC. Then the system is said to be a unstable system. Is it always necessary? Is less than or greater than? If suppose what about that equal? If exactly omega GC value is equivalent to omega PC, what it means that means positive gain margin or negative gain margin? Positive phase margin or negative phase margin? So whenever omega GC value is equivalent to omega PC, what you're getting? Gain margin is zero, phase margin is also a zero. We are not getting a positive value or negative value. The values have become zero. Zero. So that so that we will say that system is said to be a marginally stable system. So what is the condition for that? Omega GC value is equivalent to omega PC value. Then the system is said to be a marginally stable system. Okay. So remember these three conditions. When the system is stable, when the system is said to be unstable, and when the marginally stable. Condition for the stable is omega GC value should be less than omega PC. System is stable. If omega GC equivalent to omega PC, then the system is said to be a marginally stable. If omega GC value is greater than omega PC, then system is said to be a unstable system. So is it necessary to calculate everything? So no need. So from the value of omega GC and omega PC, you can able to tell that. For example, omega GC value is 10, but omega PC value is 100. Then directly you can say that we will get the positive phase margin, so system is stable. Right? Clear? So, but this is a very, very important parameter, gain margin and phase margin. So here we need to remember the four definitions. What are that? What is the meaning of gain margin? What is the meaning of phase margin? Gain crossover frequency, phase crossover frequency. Okay, then once again we will recollect that gain margin is the reciprocal of magnitude, which is calculated at a frequency of phase crossover frequency. Okay, second one, phase margin. It is the phase margin, the additional amount of gain which are added to the given system. That is gamma equivalent to 180 plus pi GC. Where it has to be calculated, it is calculated at a frequency of gain crossover frequency. Okay. What's the meaning of gain crossover frequency? The frequency at which the magnitude is 0 decibels. The frequency at which the magnitude is 0 decibels. That frequency is known as gain crossover frequency. Next, phase crossover frequency. What is phase crossover frequency? The frequency at which the phase angle is minus 180 degrees is known as phase crossover frequency. So in order to represent that, first we need to draw the magnitude plot and then we need to draw the phase plot. From the magnitude and phase plot, we are going to calculate gain margin and phase margin. From the gain margin and phase margin, we are going to calculate whether the system is stable or unstable or marginally stable. Clear? Okay, then we will see the one model problem in the next class. Thank you.